Hello guys, welcome to the new video again. We will start in this video. We will cover the topics of these topics. DFA. We will study in detail DFA today. Right? DFA in details, understanding DFA, construction of DFA. We will see. We will in this we divide construction of DFA in different modules. So models we can say. So we will see first, second. If we can cover third also. Right? So DFA and this is all right. So we are going further. Is what is DFA? So we as we see earlier, DFA the definition. So deterministic finite automata, right? So input W. So what DFA accepts a string, and if it so let's begin with a different approach. Let's say we designed a finite automata machine which to accept a language, particular language L, right? So so if there is a string W, all right, if it belongs to L, then exactly one path exists, all right, exactly one. In the case of DFA, deterministic, exactly one path. If it belongs to L, that holds at final state. Okay? Final state means accepting state. Yes, accepting state, right? So this is fine. As you can see, it's two is also fine. Right? Yes. Accepting state. So if it holds at accepting state, then it belongs to L. And if it does not belongs to L, then exactly one path exists that holds at non-final. Right? So in case of this, exactly one path is the right, which holds at non-final. Okay. So let's see further. So this is the one case. All right. So there is a deterministic automata in this, as you can see. This is DFA. So it what we can say, we designed it will accept a particular string. So let's say it can accept a, yes, it can accept it because for a this goes to this 2, which is a final state. AB, yes, AB, it goes to final. But for B, only B, right? For B, this does not, because it also which state it is non-final state, which means B does not belongs to L, right? Yes. So epsilon, because epsilon can only take as to initial state, which is not a final state yet. So this will not accept a null string, empty string, or we can say zeroth string. It will accept A, yes. It does not accept B, no. Double A, yes. A and uh, it will not accept double A also, because for first A it will goes to 2 and for second A it will goes to 1, which is a non-final state. and it will not accept this. For AB, all right. For AB, yes. For A, this will go. For B, it all set on 2, so it will accept AB. BA, yes. BA is also accept. BB, it does not accept BB, right? So this is the we can say the function representation also function representation. This is the transition function, we can say, right? So what's next is so this is a DFA, right? One, and this is a uh, state two, right? So so in this, so is it DFA? The question is it DFA? Is it deterministic, right? So is it deterministic automata? Because for one, for state one, in input symbol A, it can go to one or two. So what we saw is for successful, for accepting, and for or we can say for valid or for non-valid, for both, right? That there is only one path, right? So we can, yes, only one path is there. So there are two paths. Here is one for successful, one for unsuccessful, because uh, if it also at one, the string is not belongs to n. If it also at two, it belongs to two. So this is the case that there is two path for one input symbol from a state. So is it a DFA? I think so. No. So I don't think. I mean that it is not a DFA because it does not satisfy the condition. All right. All right. So definition DFA definitions is only because there is only one state. All right. So there is one state and there is one input symbol. For that, it will goes to only one next state. All right. So there is no that this is not 2 to power q, that uh, set of states. Note. So this is not the case. So in this, we will go to only one state. All right. Only one next state for input. From every state, from every input symbol, from every state, for every input symbol, exactly one transition to next state, as we see, as where for all W belongs to epsilon string, exactly one path exists. All right. In DFA, only one path exists. Right. Every string, valid string holds at final, and valid string holds at non-final, but there is only one path exist. So this is not the case that there will be no case for which one path going to final and one path going to non-final, or in the case of multiple finals. All right. For A, it will goes to let's say this is two, this is three. All right. This is it's equal to two also, and for A this is equal to one also. This is also not the case. Only one path exists for every string exists in this world. So identify correct DFEs uh, for this. Okay, for this. So what we can say that correct DFA. What is a correct DFA? for a comma b, right? Is this a correct DFA? What it can accept? This is not a correct DFA because there is no transition for b, all right? So this is not correct because for per state, so this is for every state, for every state, there should be a transition for every input symbol, right? So this is also the case. This is for B. There is a transition for B, but not for A. This is not a proper DFA. There is a transition for A, but not for B here. This is also not a proper DFA, correct DFA. This is transition for A and B, and this is there is also A and B. So this is correct DFA. All right. So this is also correct DFA. This is also correct DFA. Right. We can say comma or this is the same. These both things are same. All right. And final states, there could be a set of states for final, right, which belongs to a set of states. Uh, but that means F is a set of final states. Zero final states could be possible. One final state would be possible. Two final states could be possible. Three and more, so on. All right. There could be more than zero or one possible, either A or B. This is also we can represent. Or let's say this is one, this is two. So we can say that A, this is transition for B, or we can say A comma B. So this representation are equivalent to each other, right? So next is note Q is equal to N, all right? So the number of states is equal to N. If the number of states is equal to N and number of input symbol and input alphabet is equal to K, all right? So for each, right? For each state there is k transitions also, k transition for each. For how many how many transitions in DFA will be n into k, n times k transitions will be there, or we can say this, or we can also say this, right? Yes. Universal set minus L. So we can say that if we want to find the complement of a language, all right? So what does that mean? I mean, all right? So this is a universal language, universal set of language, all right? And this is L, all right? If we want to find the complement for L, so then it would be uh, L complement L universal language minus L, all right? This is the complement. So what does it mean? If a string belongs to L, all right? It belongs to L, then it does not belongs to L complement, or and vice versa. If W does not belongs to L, then that string should belongs to L complement. All right. This is the case of complement. So we can Venn diagram we can also see that this is a universal language. This is a small part is the language L, which W belongs to this. If there is a string here which does not belongs to here, then it surely belongs to L complement. All right. This whole area is all L complement, right? So if there is a string here, all right, so L complement is this, all right, not this here. This if it belongs to L, then it will does not belongs to L complement. This is the case. If L and L complement, we union them. If L this and this is L complement, if we union them, it will build this, right? L intersection L is equal to 5 also. Yes, because uh, L intersection L complementary is equal to 5. So this is also the case, I think, which is how we can see this is. So if L complement and L is equal to 5, this is also the case. All right? 5 empty set. So remember this also. Model 1, special problems. All right? Special problems means, so they, how do we construct it here? We will, special problems would be for complement to each other. All right? L1 is equal to 5, which is empty set. L2 is L. Yes, complement to each other. So phi is complement. Phi complement is plus star and epsilon star is equal to phi. Yes, this is the case. All right. So L1 and L2 are complements to each other. Yes. L3. So there is a language L3, all right, which contains only zero length string, and is L4, which does not contain a zero length string. So what is this? So this is what we can say that L3, these are complement each other. So should be union of them should make, I mean, universal language. Yes, epsilon union this, I think will make this. Yes. So these both are, I think, these both are complement to each other. We see, we are see. So complement to each other because it does not contain epsilon. It only contain epsilon. So these are complement to each other. What is model 2? Special. Model 1, special. How we construct a DFA which accept on empty language that over this, right? So so there is no, I mean, string or symbol available in the language. How we can generate for this? So for over, alright, epsilon. So there is no language, then there is no acceptance. I mean, this is not even accepting this, right? There is no final state here because there is no symbol there, alright? Uh, if there is no symbol, then there is no final state, there is no acceptance for this because language is empty. For what we are going to accept, right? Language is empty. When the language is empty, there is no final state. So the minimum DFA for this, or we can generate infinite number of, I mean, we can say DFAs, all right? We can generate infinite number of DFAs for a particular language as we want, but minimum DFA is unique always, all right? Minimum DFA is unique always, but we can generate this all are equivalent. All L is empty over a comma B. This is also, I guess this is minimum behavior for this. Minimum minimum DFA. Then epsilon is A for A B B, but there is no acceptance state. I mean, right? There is no acceptance. There is no acceptance, then there is no language. So next is, so there is note, right? For every regular language, number of DFAs is equal to infinite. Yes, we are saying for every language there are infinite number of DFAs. But for every regular language, alright, the number of minimum DFAs is always one. Unique, only as I say earlier. So minimum DFA, minimized DFA we can say is minimal DFA also. There's DFA with minimum number of states. These are similar terms to uh, terms for minimum DFA, alright? If DFA has only non-final states, number of no final state, there is no final state, then L language of DFA is empty. There is, there is no final state, the language is empty. If DFA has only one final state, no non-final state, acha, all right. If DFA is only final states, then all states. If DFA is all states, I mean, are final, right? So then, yes, the language of DFA is strict because we can say that for every we have to there's two states, all right? A comma B, because for every state from every state there should be uh, transition for every symbol and A comma B. Let's say we can this, and we make both of them final states. Now it can accept epsilon, it can accept A, it can accept B, it can A, it can accept any string from the universal language. All right. So the language of DFA will be this. All right. So DFA construction of DFA for as I mean uh, full alphabet, inclusion of full alphabet of this, whereas A is the this involve alphabet contain only A, so it can minimum DFA. We will go for minimum DFA, right? Always, right? In the exam. So so there is only A. So what we can say is A. So for A, how can I say that? Because what are the strings it can generate? All right. It, the strings it can generate is it can generate epsilon, yes, it can generate A, it can generate this, it can generate this, and so on. All right. So we for minimum DFA epsilon it accepts epsilon. For A, yes, is except for double A, yes, 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 and yes. All right. So this I will say accept. This is the DFA for that. For A comma B, this is the minimum DFA. All right. It can so firstly only generate. I mean construct DFA for minimum or minimum length strings. All right. Unique minimum length strings. All right. Unique. So this is the unique. It can generate epsilon. It can generate A, B, now A, B, and then so on. So this for this we can generate here so A and B. Now it can accept all the strings generated by this. All right. Yeah. For ABC, this is the ABC. For symbol this is the these all are same, right? Yes. For L is equal to epsilon, all right. So because L is epsilon, so over A, all right. It will accept null string, but whenever they see input symbol A, all right. So it will go to over A, because there is only one input symbol in one bracket, so there is only one transition from every state, right? So if it see a input symbol A, so it will goes to a dead state, we can say. From there, dead state, or we can say no special non-final state, from where there is no no chance to escape, all right? L belongs to epsilon over a comma b, so epsilon is accepted, a or b, which will go to non-final state, which is a dead state, or we or say dead state, from where there is now the string is that, let's say there is was a string ab, all right, which will take it to dead state, and which is the, if it holds at where it will hold at this, at the end, which is this a final state? No, that means it is a invalid, all right. Yes, if it holds at a non-final state, it is an invalid string. This is the only rule, right? Basic and only rule. L goes to epsilon plus over a, so this will not I mean accept this, all right, epsilon, all right. So minimum string it can language contain is a this, so minimum it should it accept a, then a it will accept and more of them, all right. Yeah, also this is a or b, this is the case, well, you can understand easily. Special non-final state, from this non-final state there is no path to final, we can say dead state or trap state, all right. There is no path to final we can halt ever, right? DFA, yes. One is final, yes. Two, three are non-finals, yes. Two and three are dead states, yes. Two and two is a dead state, is it? For A, for A, B, 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 A. These are two dead states, yes. We can say. So where are we? So note, if L has minimum DFA with n states, right? If L has minimum DFA with n states, then L complement has minimum DFA with n states also. This is the rule. Remember this for the exams. It could put us for 1 mark. So this is the, if L has minimum DFA with n states, then L has minimum DFA with n state also. L complement. So if the complement, this is also the case that if L is has minimum DFA with a minimum states, then L has minimum DFA with, then L complement also has minimum DFA with n states, right? So minimum DFA L, minimum DFA L complement. No, only interchange, only interchange finals to non-finals and non-finals to finals. Alright, this is the case. So, model 2 length-based problems. Length-based problems, this is the model 2 for L1 is equal to W across B, length of W is. So, first we will generate a regular express. All right, we will build a we will represent it in a regular expression as we saw earlier in the videos. All right, so earlier we saw how we can generate that. All right, or so w belongs to a comma b asterisk. All right, a comma b closure. So where the length of string is 2. So this is the regular expression for this. This is the regular for this. This is regular expression for this. Yeah, final state 1, 2. If there is more than two edge, it will go to dead state. This is dead state. This is final accepted. 3. This. These all are regular expression. We already saw. So how can we solve the length-based problems? All right. So if the length of is 2, set of all two length strings. Yes, set of all two length strings, which are these, or we can say a comma b, a b, b a, b, b b, also a b comma a b, so a or b, or we can say a or b, a or plus b equals square, the square. This is the simplest form to do build the construct the DFA. So from initial state a comma b, we will transit to 2. If this is a comma b, again a or b, so it will accept. Again we receive any a comma b, then it will go to dead state, right? If a does not be a, no, yes, a3. So note length of this is a note to remember. If the length of string is k, then k plus 2 states are required in DFA, right? The two length of here is 2, now 4 states are required. All right, so this is the formula. This could be asked in exams. How many states are required for minimum DFA when the length of a string is k, not k plus 2, not here. If the length of a string is 3, so how many? 3 plus 2, 5 states are required. So exactly n length string a plus b n times and by 2 states in DFA. This is the case, right? So length of W is less than or equal to 2. W belongs to a string. Length of string is almost 2. Also for this length based, this is also length based. So length of string is almost at most 2. Alright. So for A, W is belongs to A string. So what it could be epsilon, it could be A, it could be A. Epsilon, first we uh, made this final state. For this, we made this final state. For single length string, for two length string, we made this final state. Alright. But if the length goes further for length 3, right? So we made this non-final, alright? And this is a dead state. And this will eventually it will hold text non-final and it will be a no invalid string. Length of W is less than or equal to 2 a string B. This is a this, yeah, this is interesting case, alright? At most 2, it would be epsilon, it would be A, it could be B, or it could be uh, square for this, like this. Yes. So we can accept epsilon, yes, serialization. We can generate A or B, yes, A or B. We can generate AA, yes. We can generate AB, yes. First, then BA, yes. BB, yes. So for B, AB, for three length, alright. So if length of string less than is equal to n, alright, there is n plus 2 states required. If also is equal to n, then it is also n plus 2 states are required for both of the cases, alright. In the length way, this is the important note to remember. If L is equal to W, W belongs to a string, W is greater than or equal to 2. If the length of string is greater than or equal to 2, then length of string is at least 2. So at least if this is 1, this is 2, and it could be more than goes to 2. So W string is belongs to a string. But it will not accept this, it will not accept this, it only accept this and again. Length of 0, 1 does not accept this, yes, accept. If W length of A is greater than n, then only n plus 1 states of DFA is required, right? There is no dead state required in this case, right? For at least cases, for at least length cases, no dead state, right? So what we are seeing is that if W belongs to A and B and length of W is or at least 2, alright? At least 2, then what are the minimum string it can generate? AA, yes, AB. So minimum string it can go to is A plus B square, then AB string, alright? So for this we required how many states? 3 states and plus 1. For so 3 states we are requiring. So A comma B, yes, this is for A comma B. This is the case already given. X plus x. These are all regular expressions equivalent to this. Alright. Assume x is equal to a plus b. So a plus b, a comma b, and this is a comma b goes to a comma b, and also at the final stage only n plus 1. I mean n plus 1 what means at most 2 t. That was at most 2. Then length of is 2 plus 1 is equal to 3 number of states are required and minimum DFA for this case. Exactly angle length n plus 2, n plus 1 always, but plus 1 is dead state, alright, at most and at actually one length, but there is no dead state is required for at least cases, then it is n plus 1 states required only, alright. So what's it next? W belongs, W length of W is 1024 with uh, which belongs to this. So how many exactly? Then n plus 2. That means 1026 states in DFA. This is the question. L1 minus L2 is equivalent to L1 intersection L2 complement is equal to L1 minus L2. Because what? See, because what is L1? Let's say this is L1 and this is L2. L1 minus L2 should be this. So minus this is this. But if we are trying to L1 minus L2 complement, if what is L2 complement? What is L2 complement? L2 complement is things which does not belongs to which does not belongs to L2. Alright, which this is a universal language. This is L1. This is L2. Which does not belong to L2? This part. I mean, how can I say this? This whole part does not belongs to L2. Alright, this whole part. This whole part does not belongs to. This is the case. So yes, then intersect that intersection with this, with L1, this intersects with L1, intersects with L1, this green thing. So what will left over is this. Leftover things would be this. All right. Yes. Final total represents L value string, not string, a preset empty expression. This is model third, number of symbols. Number of age equal to 2, number of is age less than or equal to 2. This will we will I mean study tomorrow in the class, in the next class I mean. So yes, thank you so much for watching the video. We will meet guys with you in next one. Thank you so much.